Hi there, welcome to your lesson on Venn diagrams and two-way tables. In this image here, you can see an example of a Venn diagram. I think this is something you're probably familiar with. Venn diagrams basically are a way of representing sets and where the sets overlap. For example, this full circle here represents zombies, and then where that circle overlaps the other circles represents the traits that are shared by zombies and these other things, such as robots and aliens. And the intersection of all three we can see here is death to humans. All these things want to cause panic and destruction. Okay, let's look ahead here and look at Venn diagrams applied in a mathematical way. But before that, here's some other Venn diagrams. Here's one. We have our happy relaxation circle and our crushing depression circle. And the intersection of those two is Sunday night. That's kind of funny. Okay, and another one. Take a look at this one. Santa at the heart of this Venn diagram. The intersection of great power, great responsibility, knows if you have been naughty or nice, and wears a red suit. Well, what is the one thing that has all those qualities? Santa. And then there are zones in this Venn diagram. It's important to know that where only two circles overlap. For example, the great power, great responsibility, and wears a red suit circles overlap right here. So we can see that's Spider-Man. But this overlap does not include this circle. So the overlapping regions are the key to Venn diagrams. Here's another one. Here's a circle representing all cool things. Here's a circle representing useful things. And the intersection of those two, cool things that are useful, and that is what Iron Man has, Tony Stark, and those are things that I want. Okay, so moving into a mathematical example here. We have a group of 30 children. 9 children like only vanilla ice cream, 13 like only strawberry ice cream, and 5 children like both. So as soon as you see the word both in the description, you're thinking about where the circles might intersect. So I want you to give this one a try. Draw a Venn diagram for this one. And it will be two circles. There will be a vanilla ice cream circle and a strawberry ice cream circle. And they will intersect. So what will that Venn diagram look like? And tell me what the three numbers, actually there's 4 numbers, because there'll be 3 numbers within the circles and then a number outside both circles. So what will the 4 numbers in order be if you started with the vanilla circle on the left? Let's check our work. Your Venn diagram will look something like this. And now let's check how. Let's say that A again, that set A is vanilla ice cream likers and set B is strawberry ice cream likers. So again, what will the numbers be? Here, 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 and then outside. Okay, check how you did. So we were told that there are 30 children and 9 only like vanilla ice cream. So if this is the vanilla ice cream circle, that should be all the kids that like vanilla. And we're told that 9 like only vanilla. So that goes here. Because this part in blue here is the intersection. Those are the ones that like both. So again, you look here, you're like both. Oh, 5 children like both. So 5 goes there because the overlap is vanilla and strawberry liking people. And here's 9 vanilla only, and we're also told 13 like strawberry only right here. So look at those numbers, add them up. 9 plus 5, 14 plus 13 is 27. So we know we've accounted for 27 children within the circles, within these sets. And we know there's 30 in total. So there must be 3 other children that do not like vanilla, do not like strawberry, and they're outside both circles right here. Okay, great. That's a basic Venn diagram with 2 sets of things. So now let's use the Venn diagram to find probabilities. So this part B says here, what is the probability that a child picked at random? That means if you took this whole group of 30 and you randomly selected somebody from the group, what would be the probability that they like strawberry ice cream but not vanilla? So think about how we set up basic probability. It's always the number of items you have in meeting a specific condition over the total number. So what would that be? And then part 2 says, what's the probability you'd pick a child at random who doesn't like strawberry or vanilla? So let's see what you come up with. And now let's check our answers for that. So the probability a child likes strawberry but not vanilla is 13 out of 30. Because we have here, the children that like strawberries 13. There's 5 that like both, of course, but we were told like strawberry but not vanilla. So we're talking about only these kids. And so that's 13 meeting that condition out of the total 30. This S, by the way, means sample space. So this rectangle represents the full sample space, or all the things that are being considered in this situation. So 13 out of the total 30. And the second one, probability they like strawberry or vanilla. Okay, so strawberry or vanilla. By the way, or when used in probability, I think we've talked about this, means this thing or both. Okay, so we're looking at for everything inside both circles. That's why we get, oh wait, sorry, doesn't like, I'm sorry, doesn't like. Because the liking strawberry or vanilla would be everything inside. But doesn't like strawberry vanilla is those 3 on the outside here. So 3 out of 30, which reduces to 1 out of 10. Okay, so I think you're definitely ready to try one on your own. Please read this situation, draw the Venn diagram, and then answer question B. Let's take a look at the answer here. So here is our Venn diagram representing 40 people. 35 choose the main course, 10 choose a starter, and 7 choose both. So like I said, try to always begin with the both if you're given that. So 7 choose a main course and starter course here. And then 35 choose a main course. Now I want you to notice how this is different than the last problem. Last one it gave us the both number, but then it also said only vanilla and only strawberry. This one does not have the words only in it. It says 35 choose a main course. So that 35 must represent all the people that chose a main course, including the ones that chose the starter as well. So here's your 35 in total here. You can see 28 plus 7 makes 35. So again, you begin with 7. You know the whole circle is 35, so you can do 35 minus the 7 to get that number. And we'll do the same thing in the second circle, those who chose a starter course, because 10 chose a starter. It doesn't say only 10, sorry, it doesn't say 10 chose only a starter, because then that would be a 10 here. It says 10 chose a starter, so that means this full circle has to be the 10 people. And we know there's 7 there, so there must be 3 there. So that was the first little trick to that one, but I hope you can see in the words why we came up with this Venn diagram. And again, if you add up the numbers on the middle, that gives us 38. So that means there must be 2 other people remaining on the outside here, because we had 40 in total. Okay, and the probability a person picked at random chooses a main course but not a starter. So that means these people here only. So it's from the main course circle, but it's the ones that chose only a main but not the starter. So 28 out of the 40 reduces to 7 out of 10. So maybe you didn't get that one, because again the wording was a little different here, but I hope you did, and if not, I hope you understand what we talked about here. Let's move on to another one. This one's a little tougher. Here we have more information given to you, right? So much more. And the reason is this is going to be a Venn diagram with 3 circles. It's going to be something like this. There are 3 situations talked about here: lacrosse players, basketball players, and volleyball players. See if you can read these words and very carefully consider the words like all or some or anyway, that you look at the words very carefully to know exactly which of the zones it's talking about, and give it a try. Fill in the Venn diagram to start. Okay, here's the Venn diagram you should have. Take a look at your numbers very carefully. Here's lacrosse, basketball, volleyball. I'll give a couple examples. 3 children do not play any of these sports. So here's the 3 on the outside. 2 children play all 3 sports. Okay, that's the one that's all 3. So that's the overlap of all 3 circles in the middle here. 6 play volleyball and basketball. Now look at that one very carefully. Volleyball and basketball. Here's volleyball. Here's basketball. Here, right here, is the overlap of volleyball and basketball. So a mistake that's commonly made is students would write the 6 here. But we already had the 2 here that play all sports, and we know that this whole zone is volleyball and basketball players. So this must be 6 in total here, and if we knew this is 2, this must be 4. And now you might want to adjust your other numbers based on that. So take a look at these words again and see if it makes sense there. But regardless, now that we have the Venn diagram, we can answer some questions. So try to answer B1 here. Okay. And B2 and 3 as well. Here's the answers. Check your work as well. And just take a look at where those numbers lie on here. Okay. So only lacrosse, for example, here. Volleyball and basketball, but not lacrosse. So volleyball, basketball here, but not lacrosse. So this one. And the last one plays only volleyball. So over here, the 2. Great. Let's move on to the next topic of this video. Those are Venn diagrams, and here's what's called a two-way table. Two-way tables capture data about two different variables. Okay, so here we have obviously gender here, and here subjects they study, and it says the total number is 150 students. So we have 150 students represented in this table. For example, 40 males study science, 15 females study science, in total 55 study science. Okay, so find the probability a student chosen at random from this group is male. Okay, what do you think? Okay, the answer for that is 91 out of 50, because you look at the male row here, you add up all the male students, all these numbers here, and you'll get 91 out of the whole 150. Okay, next, probability that it's either male or studies science. So now males or people who study science. Take a look at the answer here, 106 out of 150, because we have all the males here, which we already had is 91, and then the people studying science here. So you're going to have the 91 plus 15, because it's that extra 15 females that also study science. You don't have to count to 40 again, because we've already included it here. So 91 plus 15 gives us this. Okay, last one. A female student is picked at random. Find the probability that she studies arts. So this one's very important to note the wording as well. A female student. So now we know we're only talking about females, and we want to know the probability she studies arts. Okay, here's the answer for that one, 20 out of 59. So here's the arts. We don't consider this because those are males. We take only the 20 female art students, and we say 20 out of the total female students, because it's female students selected. So now we're ignoring all the male numbers, and we're saying 20 out of this group on the bottom. Okay, now that you've seen how a two-way table works, try this one out. Find the number of male diners in the restaurant, the number of diners who ordered chicken stir fry, and then the probability that a randomly chosen dish was chicken stir fry for a female diner. Okay, check your answers here. Hope you came up with that. And now, next question. So we have another one for you here. The table isn't given, so I want you to read the information that's given, create the two-way table, and then use the two-way table to answer question B. Let's see if you can do this. So here's the table. Again, compare to yours and take a look at the numbers that are given. 16 total. So you can see here's male, female, and we added these total columns here. Okay, I don't think we had that in the last one, right? Let me double check. Yeah, we haven't had the total columns yet. So in this case, we have the totals given, because that might help us. But anyway, here's the main things you should have entered. And now, what's the probability that a student chosen at random is an advanced male snowboarder? Okay, it's 10 out of 60. So here's advanced males, and out of the whole 60 here. All right, so 10 out of 60. Okay, I think that's it. So great job. I hope you have a kind of a basic understanding now, a better understanding of Venn diagrams and two-way tables. Great job.